For this part of math, we are going to talk about complex numbers. What are complex numbers? Then we'll go to how to add complex numbers, how to subtract them, how to multiply, and how to divide. Okay, we know that we have real numbers, we have natural numbers, we have integers, we have rational numbers and irrational numbers, and all these numbers called real numbers. And we know that, and we studied that before. Related to complex numbers, there are two parts that when a number is called complex, it has two parts. One part is real and one part is imaginary. What is imaginary numbers first? If I tell you now a square root of 4, you're gonna tell me it's 2. Square root of 9, you're gonna tell me it's 3, right? Square root of 1, you're gonna tell me it's 1. But when I tell you square root of negative 1, you're gonna tell me it's what? So look, a square root of 9 is the question that what is the number that when you multiply it by itself, we get 9. So it's 3. So when I tell you square root of 4, that means I'm asking what is the number that if I multiply it by itself, I get 4. So it's 2. And when I tell you what is square root of 1, it means what's the number that when I multiply it by itself, I get 1. Good. But here now, when I tell you square root of negative 1, I mean what is the number that when I multiply it by itself, it will give me negative 1. Is there a number that I multiply it by itself and I get negative 1? Is there? Okay, if the number is positive, if you multiply it by itself, it will give you a positive result, right? Positive 2 times positive 2 is going to give you positive 4. If it is negative by itself, it will give you also positive. So negative 2 times negative 2, it will give you also positive 4, not negative 4. So that means, is there a number now, if I multiply it by itself, it will give me a negative number, like negative 1 here? No. So no real number that I multiply it by itself and I get negative number. Good. So that means a square root of a negative number, this one is imaginary number. That means we imagine there is a number there, but real, it's not there. So you imagine it, it's there, and we call it I. It means why? It's the first letter of imaginary. So that means the square root of negative 1, and keep it in mind, the square root of negative 1 is I. Keep this one now in your mind, and you understand why, because it's not longer real number. So a square root of negative 1 is not 1, it's not negative 1, it's just what? Imaginary number that we imagine it's there, but it's not there. So we call it what? I, like imaginary. Good. So that means now, if I tell you now what is the square root of negative 25? Look here how you're gonna do it to me. Look, you're gonna change it to be 25 times negative 1. You see? Yes, because negative 25, it means 25 times negative 1, right? Now you can distribute the square root for both of them. So that means it's gonna be square root of 25, square root of 25 times a square root of negative 1. You see now? So what is square root of 25 now? We know what it's 5, right? And what is square root of negative 1? We know what it's I. So that means it's 5I. Another question. If I tell you now what is a square root of 36, what are you gonna do? Look, you're gonna make it to be 36 times what? Times negative 1. Right? Then you split here, it's gonna be square root of 36 times what? Times the square root of negative 1, right? The square root of 36, we know that it's 6, right? And here, square root of negative 1 here, this is I, imaginary number. So that means we write 6I is the answer. So that means whenever you have a square root of a negative number, like here, square root of 49, just write the square root of 49. What is it? It's 7 directly, and write I. Look, no need to go on these steps, just keep it this way. So square root of negative 64, it's gonna be square root of 64, that is 8, and times what? I. So that means it's gonna be 8I. We understand now. Okay, now we understand, look here, that the square root of negative 1, it equals I. Good. Now, what will happen if I have I squared? So look again, if I have I, as we know, it is the square root of what? Of -1. Good. If I have I squared, I squared, it means I times I, right? And I times I, it means the square root of -1 times the square root of -1. Good. Square root of -1 times square root of -1 equals what? Keep in mind that the square root of 3 times the square root of 3, it gives you 3. The square root of 5 times the square root of 5, it gives you 5. The square root of x times the square root of x, it will give you x. So square root of any number times the square root of the same number, the two roots will go out, and what will be there is just x. So that means here now, a square root of -1 times square root of -1, it will give you what? -1. Keep in mind. So that means now what you need to remember is I squared, it means -1. Good. So you understand now what is I squared. We go to the third step, which is what? Which is I power 3. If it is I power 3 now, can I rewrite it to be I squared times I? Yes. I power 3, it means I squared times I. Good. I squared now, we know what is it. What is I squared? It is here. You see, it is -1. So it's -1 times what? Times the I. Good. So that means -1 times I, it's -I. Keep that in mind. Okay, now we understand 3 steps. What is I? What is I squared? What is I power 3? Okay, if we go to I power 4, what will we get? Isn't it now I power 4? It means I squared times I squared. Yes, and I squared is -1, right? Times I squared, which is -1. -1 times -1 is 1. Keep that in mind now. Look here now what we have here for I. For I squared, it's -1. For I power 3, it's -I. For I power 4, it's 1. Okay, if I continue now, look, if you continue to get I power 5, look, and I power 6, no new results you will get. No new result. Now, whatever is the power of I, the results will be only 4 results. Only 4 results. What are they? This is one result, this is the second, this is the third, this is the fourth. So whatever is the power of the I, the result will be one of these 4. How do I get that? So if I have now I power 5, isn't it I power 5, I power 4 times I? Yes. And I power 4 is 1. I power 4 is what? This is 1. So 1 times what? Times I. It will give me I again. You see? It will give me what? I again. Okay, what about if it is I power 6 here? I can write it like I power 4 times I power 2. Good. I power 4 is 1. 1 times I power 2. I power 2 is -1. So then this is going to be -1, which is I squared. So now what I need you just to focus on is the following. Whenever is the I, look, I power 18. I power 18. Okay, whenever I power 18 or I power 100 or I power 300, okay, this I subtract from its power the closest number that is divisible by 4. So now this is 18. This is what? 18. Subtract from the 18 the number that is divisible by 4. What is it? 16. So subtract 16 out of 18 because now I power 16 will give you 1. And 1 times any number will not change anything. So that means now just I write it by what is result is I power 2. Good. If I have I power 25, you see, I power 25. Now 25, what is a number? The closest number to 25, but less than 25, that is divisible by 4. What is it? It's 24. So that means I power 24, you subtract it out of this one. What is left? What is left is just I power 1. Get I power 100. You see? I power 100. Is the 100 divisible by 4? Yes. If it is divisible by 4, the result is 1 directly. So keep in mind now. And now we understand. I power any number, you can change it to be I power a number that is the remainder of the division by 4 for any power. Okay, for example, now if I tell you I power 43. Look, I power 43. What is the number that is less than 43, but the closest one to 43? And that is divisible by 4, it's 40. So subtract 40 now out of the power. What will be left is I power 3. So now look, always the results will be as you see, I power 3 or 1 or I power 2. So that means it will be only one of these 4 as we said. 1, 2, 3, 4. These ones are the results of I power any number. So I power any integer, any whole number, it will give you one of these results. And I hope that is clear. Okay, now we understand what is imaginary number, and we understand how it is when it has what? Powers. Good. If I tell you now the square root of negative 25 again, if you look, negative 25. We said just you write square root of 25 is 5, and you write what? 5i. Now this one is 5i, this number. Now, this number, is it imaginary or real number? It is imaginary. All of it, 5i is imaginary number. And 5i is a number. All of it is just one number. Don't tell me the 5 is a number and the I is a number. No, 5i, both of it, as long as it is multiplication, we deal with it like one monomial. So that means it is one number. And this number is what? Imaginary number. Good. If I have now a number that is 5 plus 3i, you see? This number now, all of it, is it imaginary or real? Is it imaginary or real number? Look, this number now when you have plus or minus, that means you have more than one number. Here now you have one number, and here you have one number. So this number now is real, plus this number is what? Imaginary. So you have two parts in this number. Now you have two parts. One part is real, one part is what? Imaginary. So in this case, we call this one what? Complex number. We call it what? Complex number. So what is complex number now? Is a number that it has two parts. One part is real, and one part is what? Imaginary. Okay, these complex numbers now, we need to understand how to add them, how to multiply them, how to subtract them. Very easy. Look here now. If we start by addition, if I have 1 plus 2i, this is now a complex number, plus another complex number that is 3 plus what? 5i. Okay, these ones now I need to add them. I need to add them. How do I add them? Just add what is real with what is real. You see, and the result will be real. 1 with 3 is going to be 4. Done. I finished now what is real. And now add what is imaginary with what is what imaginary. 2i with 5i is going to give you 2i with 5i is going to give you what? 7i. And that's the answer. You see? So a complex number plus a complex number, it will give you what? A complex result. This is for addition. Okay, what about for subtraction? Same way. If I give you 3 plus 2i plus, look, even minus here, we're gonna deal with it. If it's a minus, and here now I'm gonna just change. If I give you now here 5i plus 3, you see? So look, now this is complex number and this is complex number. This is complex and this is what? Complex. You have two complex numbers and you have subtraction between them. When you subtract the real from the real and the imaginary from the regardless of what is the order. Regardless of what is the order. So here now, I'm going to start by the real. 3 minus 3 will give me 0. So that means for the real part, it's 0. Okay, now, what about the imaginary part? I deal with it like this way. 2i minus 5i. 2i minus 5i is negative 3 what? I. So that means the result is negative 3 what? I. You see? And this number is no longer called complex. It is just imaginary number. And I hope that is clear. So that means when we add and we subtract complex numbers, it doesn't mean the result will be usually complex. It can be real, it can be what? Imaginary, it can be what? Complex. And we understand here now. So when we add the imaginary part with the imaginary and the real with the real. Okay, if I give you now a third point, if I give you negative 3i plus 2 plus 2i. Look here now. I'm making addition here. This one is imaginary. and I'm adding it with what? With complex number. What I should do here? In this case, what to do is just add the imaginary with the imaginary and leave the real as it is. 2 is real, leave it as it is. In addition and subtraction, real is only with real. Okay, now negative 3i with 2i, it's going to be negative what? 1i, which is negative I, so this is the result. You see? So you understand now how to add and how to subtract real imaginary numbers or complex numbers. If I give you negative 3i plus 8i, here just you add them because both what numbers are imaginary, you add them and the result will be what? Imaginary. Good, you understand now how to add and how to subtract. Good. If we go now to how to multiply, look here now. If I tell you now 3i times 6i. So look, this is now imaginary part with imaginary part, and I'm multiplying it. 3i times 6i will give me what? Look, 3 times 6 will give me 18, right? And now I times I will give me I squared. Keep that in mind. Now, as we studied before, in this recording, what we studied in the beginning, we said I squared, you need to memorize it. It equals what? I squared, we said equals negative 1. So that means now it means 18 times negative 1. 18 times negative 1 will give me what? Negative 18. You see? Now I'm multiplying imaginary times imaginary, but the result is real. The result is real number. Because when I multiply I times I, the result will be I squared. And I squared is negative 1. And negative 1 is real number. But the square root of negative 1 is not a real number. It is what? Imaginary number. I hope that is clear. Okay, if I tell you now another question. If I give you negative 3i times 5i. Okay, what will I get? Look how it's going to be. Negative 3i times 5. Look, negative 3 multiply times 5 is going to be negative 15. Good. Now, I times I is going to give me what? I squared. Now, negative 15i squared. So it's negative 15. And I squared, as we know, it's negative 1. Keep that in mind. Negative 1 now times negative 15 is going to be positive what? 50. I hope that is clear. I hope that is clear. You can do it directly, just 3 times 5. It is negative 15. So that means the result will be the opposite sign because it's going to be I squared negative 1 times that number. It will change its sign. Okay, now we understand how to multiply imaginary times imaginary number. But till now we didn't study complex times complex. Okay, if I have a complex like 3 plus 2i, you see, times now 1 plus 3i. Here now is a complex times a complex number. How we multiply them? We multiply them same thing. We multiply what? Parentheses. How we multiply them? We multiply first times first, then first times second, then second times first, then second times what? Then second. Look what we get now. First step, this is now the first. This is the second step. Here is the third. Here is the fourth. Okay, if you go to the first step, 3 times 1 is 3. Done. Second step, 3 times 3i is going to be 9i. Good. Go to the third step. Third step is 2i times 1. It's going to be 2i. Good. Fourth step is going to be 2i times 3i. 2i times 3i is going to be 6i squared. Look here now what I do. This one now is I squared. And you know what is it? Now these two, we add them. So that means I keep 3 as it is. 9i plus 2i is going to be 11 what? 11i. Plus, here it's going to be 6 as you see. But times what? This is I squared. And we know I squared is negative 1. Now this one here, 6 times negative 1 is going to be negative 6. So that is going to be 3 plus 11i. And here it's going to be what? A negative 6. Now you can get 3 with negative 6. It's going to be negative 3. So the answer will be negative 3 for the real part and 11i for the imaginary part. And this is the result, which is a complex number that it has part real and part imaginary. This is now how to multiply, how to multiply a complex times complex number. But we have here one note, and it's very important. One note, and we have it is important. If I tell you now 1 plus 2i, 1 plus 2i. This is now a complex number. Times 1 minus 2i. You see? What do we call these ones? We call them conjugates. And remember that. Conjugates here, conjugate complex numbers are the numbers that they have different sign. Not in the middle. Not in the middle. They have different sign for the imaginary part. So look, real, this is 1, this is 1. They have the same sign, positive 1, positive 1. But if you go to the imaginary part, this is positive 2i and this is negative 2i. You see? So that means if they have different, same thing if I rewrite it in another way. I can rewrite this one in another way. 1 plus 2i, you see? You see, I can rewrite it like this one here. And negative 2i plus 1. Do they still here called conjugates? Yes, because the real number is still the same thing. You see the same sign, positive 1, positive 1. But the imaginary part, as you see here, is positive 2i, and here negative 2i. So regardless of what is the order, as long as the imaginary part, they have different signs, and all the numbers are the same, in this case, we call them conjugate. In this case, when you multiply them, you can multiply them first times first, first times second, second times first, second times second. But in order to save time, if you made sure that they are conjugates, in this case, you can multiply only the first times the first and the second times the second only. 1 times 1 is 1, and 2i times negative 2i is going to be negative 4i squared. And now we know it is I squared. So that means it's going to be 1 minus 4 times I squared when it's negative 1, right? So then it's going to be 1. Then here, negative 4 times negative 1. It's going to be positive 4. Positive what? Positive 4. So that means the result will be what? The result will be 5. Same thing here. The result will be what? The result will be 5. So that means you have to understand something. If I multiply a complex number, this is the complex number. If I multiply it by its conjugate complex number, and we said it's mean conjugate complex number, it is the number that it has different sign only for the imaginary part. In this case, the result will be real number. The result will be real number. Here now, we understand how is multiplication. And if you understand multiplication, that means you understood division. How? We're going to explain it here now. If I tell you now how to divide, if I tell you now y divided by I, y divided by I, it equals what? We know we can write it 1 over I. We can write it 1 over I. We can keep writing it as 1 over I. But to make it in standard form, get rid of the imaginary part in the denominator. So that means we don't want imaginary part in denominators. Get rid of them. How do I get rid of them? Remember what we said in multiplication. Imaginary times imaginary usually will give you what? Real number. Imaginary times imaginary will give you what? Real number. So here now, I'm going to multiply this one I by its conjugate. And its conjugate, as long as it is imaginary, its conjugate is the same imaginary, but we change its sign. So you can multiply here times negative I up and times negative I down. Then what will I get here when I multiply up? I'll get negative I. Okay, down here, I'll get negative I times negative I. It's going to be negative I squared. Again, negative I keep it up, and here negative I squared is going to be negative times what? I squared is negative 1, right? So that means it's going to be negative I over negative times negative 1 is going to be positive 1. So that means the result will be what? Negative I. You see? Okay, same thing. If I give you now, this is number 1. Number 2, if I give you now 3 divided by negative 5i. You see? Here now, it equals what? Look what to do. Get rid. On division here, it means this is division. Get rid of the imaginary part in the denominator. So go to multiply by its conjugate. So you multiply here times, look, this one now is negative. It's negative sign for the imaginary part. I multiply it by a positive sign and the same number. I multiply up and down. You see, times 5i. What will I get now? What will I get here now? Look up, it's 5 times 3, it's going to be 15i. Thank you. What about in the denominator? In the denominator now, look, when you multiply negative 5 times 5, it's going to be negative 25. Good. But I times I, it will give me I squared. Right. Now, what will I get up? I leave it as it is, 15i, and down now the denominator is negative 25 times I squared. And now we know that negative I squared is what? Is negative 1. So the result will be 15i up. And here it's going to be negative 25 times negative 1. It's going to be what? 25. You can simplify it by 5. By 5, you would get 3 over 5 what? I. And this is the result. This is the result. And I hope it's clear now. When you have imaginary in the denominator, how we multiply, just multiply by its conjugate imaginary number. But now, do we use complex numbers, or we are dealing now when we have just imaginary in the denominator? Here now, just we have imaginary part in the denominator. This is imaginary part in the denominator, and this one is imaginary part in the denominator. It's not a complex number in the denominator. Okay, now this is the last step for this lesson, which is what about when you have a complex number in the denominator, not just imaginary part? You have complex, as we said, it has imaginary part and real part. Okay, good. If I give you now 3 over 1 minus 2i, you see? So now what do I have in the denominator? What do I have in the denominator? I have in the denominator, look, a number that it has two parts, one imaginary, one what? One real. So it's a complex number. How I divide here? The goal of division for complex numbers or imaginary numbers is to get rid of the imaginary part of the denominator. So multiply usually by the conjugate that it has different sign for the imaginary part. Let's say I'm going to multiply this part now and this part by what? I'm going to multiply them by the conjugate of the denominator. Conjugate of the denominator has the same sign, same number for real number, which is 1, but different sign for the imaginary part. This is now negative 2i, so you're going to multiply here by positive 2i. You see, and here the same thing, we multiply by 2i. And I hope that is clear. Now just say multiply. How I multiply? Up in the numerator, I'm going to distribute 3 times 1 is 3. Then 3 times 2i, it's going to be what? 6i. I finished now the numerator. Okay, what about in the denominator? In the denominator, as we studied in multiplication, and I told you, if you understand multiplication, you understand division. Good. When we have two conjugates, just we multiply the first times the first, which is 1, and the second times the second, which is negative 2i times positive 2i, it's going to be negative 4i squared. Good, thank you. Now write the numerator as it is, 3 plus 6i as it is. And now you'll get in the denominator 1 minus 4 times here negative 1, which is what? I squared. So now you'll get 3 plus 6i, you see, over what? 1 minus this one here is going to be negative 4 times negative, it's going to be positive 4. So that means the result will be 3 plus 6i, you see, over what? Over 5. You can write the result as this way, or you can write it to split it. Denominator, real part alone, which you distribute the denominator for both, it's going to be 3 over 5. You distribute the 5 for both numerators. Plus what? Plus 6i over what? Over 5. You see? In this case, you have two parts, one part that is real, one part that is imaginary, and this is a complex number. So that means whenever you multiply, you divide, and you have a complex number in the denominator, just multiply by the conjugate of the denominator, and the conjugate, it has different sign for the imaginary part. Okay, just one more note. If I have now this question, if I have 3 plus 6i, you see, the over 8i minus 5. Okay, in this case now, think of it. What is the conjugate? What is the conjugate that I need to multiply now numerator and denominator by? The conjugate is the conjugate of the denominator. Good. So multiply here by the conjugate of what? Of the denominator. What is the conjugate of the denominator? Conjugate of the denominator is just to change the sign of the imaginary. What is the imaginary here? Positive 8i. So make it negative 8i. You see? And the real, leave it as it is, negative 5, negative 5. And here you multiply it by up and what? And down. So that means you multiply now. You start just multiplying. Here, you multiply first times first and second times second. While here, you multiply first times first, first times second, second times first, second times second, as we said it in a multiplication. Then you find the result. Thank you. See you in other videos. Goodbye.